So this is the 2015 Leaving Cert Ordinary Level Paper 2, and we're looking at question number 2. The line P makes equal intercepts on the axes at A and B as shown. So we can see this is the line P here, running up here, and it makes equal intercepts on the axis A and B. Part A1 says write down the slope of P. Well, if this number and this number, if it makes equal intercepts, that means this distance, the run, and this distance, the rise, are the same. So in other words, if this is the rise, if this is the run, if they're the same, they make equal intercepts at A and B, then the rise over the run will be the same number over the same number, whatever it is. So the slope will be 1. So the slope will be 1. Part 2 says the point 1,5 is on P. So that's point 1,5 is going to be up here somewhere. Find the equation of P. Write your answer in the form ax plus by plus c equals 0, where a, b and c are elements of the z set, which is the set of integers, whole numbers, positive or negative. Okay, so we're looking for the equation of a line here, and in your tables book you have some formulas for the equation of a line. So you have two choices in your tables book, and the one we're going to use is this one here. Y minus y1 is equal to m bracket x minus x1. To use this formula you need m, which is the slope, and x1, y1, which is a point on the line. So here's the point x1, y1 that's on the line, and you've got your slope here, which is m, which is 1. So the formula y minus y1 is equal to m bracket x minus x1. So we're just going to sub the values in to this equation. So this y and this x will remain as part of the equation. So we have y minus our y1 value, which is 5, is equal to m, which is the slope, which is 1, bracket x minus our x1 value, which is this one here. So again, just to be sure there, you can see that that's our x1 value, which went in here, there. And then we had our y1 value, the 5, which was here. And finally we had our m value, which is the slope, which went in there. So they did ask us to write our answer in this form though, so we're going to have to work on this a little bit. So we have y minus 5 is equal to, we multiply this out here, 1 times x is just 1x, and 1 times minus 1 is minus 1. So now we can just bring everything to one side, because we want it equal to 0, so we can bring 1x over there becomes minus 1x. And this minus 1, if we bring it over, becomes a positive 1. So we have the minus 1x, we have our y, and then minus 5 plus 1, that's going to be minus 4, and that's equal to 0. So now we have it in the form we were asked, where a, b and c are integers. So we have minus 1x plus y, or plus 1y minus 4 is equal to 0. That's the end of A part 2. Part B says the line Q is perpendicular to P and contains the point O, which is 0, 0. That's the origin. So find the equation of Q. So if we just go back to our drawing, here's the line Q. We know it's perpendicular to the line P, so these are all right angles. all right angles there. Now, if the line P is perpendicular to the line Q, well, perpendicular lines have slopes that multiply to give -1. So if the slope of P is m1 and the slope of Q is m2, if they're perpendicular, we can say that m1 times n2 is equal to -1 always. So we know the slope of P was 1, multiplied by something is equal to -1. So what do we multiply 1 by to give -1? Well, we multiply by -1. So the slope of the line Q is -1. And if we're looking for the equation, we can use the same formula that we just used before. Y minus y1 is equal to m bracket x minus x1. So this time we have our x1 value there and our y1 value there. This is a point on the line. So now we're just substituting in carefully. So we have our m value, which is -1, will go in there. Our y1 value, 0, will go in here. And our x1 value, the other 0, will go in over here. So we substitute in now, we get y minus 0 is equal to -1 bracket x minus 0. So that gives us y is equal to minus x. This is the -1 by x is -1x, minus x. We can ignore the zeros. So y is equal to minus x, that's the equation of Q. And finally, part C, the lines P and Q intersect at the point C. Explain why the triangles OCA and OBC are congruent. So we're trying to show why the triangles like this yellow triangle is congruent to this green triangle. Congruent means identical. In other words, the lengths are the same, the corresponding lengths are the same size and the corresponding angles are the same size. So what we can see here is that, well, both triangles contain the line OC. So that's the first thing we can say. So say the length of the side OC is equal to the length of the side OC. You can say that's a common side. So remember, when you're trying to prove that triangles are congruent, there's a few ways you can do it. You can prove either that the three sides are the same, side, 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 that a side, an angle, and a side with the angle between the two sides is the same. You can prove angle, side, angle, or you can prove a right angle, a hypotenuse, and another side. These are 4 ways you can prove congruency. So because our two triangles are right angled, we've got one eye on this one here. So we've proved that OC is equal to OC because that's the common side in both triangles. If we go back, we can say also that OA, this distance here, OA, will be equal to OB, because they told us that in the question. It makes equal intercepts. So that's another side that's the same. So the length of the side OA, these straight brackets mean the length of OA, the size of the line segment OA is equal to the size of the line segment OB. That we know that from the equal intercepts information. So we can just write equal intercepts. And finally, we have a right angle here and a right angle here. So both triangles contain a right angle. So that's the angle OCA, the size of the angle OCA. It's O to C to A, so this angle is equal to the size of the angle OCB, this angle. Size of the angle OCB. We can say that they're both 90 degrees. So we have a right angle. If we go back, we have a look, we have a right angle. We have the hypotenuse in both triangles, OA and OB, and we have a common side. So we have OR HS, right angle, hypotenuse, and a side. Therefore, the triangle OCA and the triangle OBC are congruent, identical in size. And that's the end of question, part C.